Welcome guys to a new tutorial. In this case we're going to be learning how to do proper chops inside Houdini. You will be able to create smoke simulations, smooth terrain, shade, and even some Nuke compositing. So stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We even have resources for every type of discipline. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you. Okay, so we are in the scene, and the first thing we got to do is to actually play with the sound. So what you're going to be doing is to create like the brain of this whole setup. Let me show you how this is done. Usually you just need a chop net, and you also need somehow to send the attributes to subs. So the first thing we're going to do is to create a simple point so we can have somewhere to store these attributes, and we're going to be creating. In this case, I decided to create, okay, this is a visual bug, don't worry about this. I decided to use an attribute called high and a cumbes. A cumbes is like, those are the bass sounds like boom, 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 but they are accumulating over time, and the bass, which are the singular bass sounds which I made. All of them are going to be floats and point, nothing else. And a channel. The channel is going to be creating basically to grab these attributes from chops and send them to these attributes to subs out of this chop net. You can see this is connected here. To visualize this line, you just now got to go to view and show for selecting nodes. So let's create this chopnet and let's go in. You will see there are a couple of nodes that you probably never used before because it is not that common to use chops if you're new to Houdini. And there is a file. This file is from a song from Masano. It's a techno song. And if we go and here, we are not going to listen to anything. So there are a couple of things to do. Firstly, we need to understand how this works. So when we are here, we need to go not to the animator editor, but to the motion effects view. The motion effects view is going to show us all of basically all of the attributes or the channels, in fact, of whatever we are listening to. In this case, this is the song. You can see it goes from frame 1 to 4000 and whatever. But our scene goes from 101 to 1300, right? So firstly, I would like to just trim what I'm going to be using. So as you can see, I trimmed the music. The trim node, it just moves basically the music in seconds, if I'm not mistaken. So I reduce it by this amount. Everything here is not going to be used, and I'm going to be saving computing power. Then what I'm going to be doing is, as you can see, let's just hop in right here. We'll see that we have two channels. You have the channel 0 and the channel 1. I decided to just stay with the channel, to just delete one of the channels, because I don't need both channels to be computed over time right here. And you will see there is a shift here. This shift is also replicated with as a reference with Ctrl, Shift, Alt, and drag. And this is basically to move our music to the first frame. What is the code? Well, basically, it's just this. Is 101 divided by 24 is going to give us the amount of seconds we need to offset. Why 24? Because if we go into our properties, we can see that the animation is set to 24. Now, you will see still that if we go here, this is the where are we at the current time frame. You will see that we are not listening to the song. So how are we going to do this? Well, you need to click here, go to Scrub, and on chops, you can just grab any node you want and press it here. You will see, now if we press play, it's here. Okay, so once we have this, we can start playing around. This is going to be our null. I'm going to just delete this because, in fact, I want to use this one, which was already created. There we go. Now, what I'm going to be doing are 2 separate or 3 separate lines. One is going to be for the hive, one is going to be for the accumulation of the bus, and this is the bus. So let's begin with the first one. And this is a very cool thing you can do to understand what's going on. Firstly, let's just go here and listen to what's going on. This is a bus parametric equalizer. I'm basically choosing the frequency I want to keep. Now listen, almost just the bus. I can play around with this, and I'm just staying with a frequency. This is very cool, because then I can isolate it later on with, for example, let's just move on to here, and I'm limiting this because I don't want any value native in my playlist. Remember, we are going to send this to sub, so it doesn't really make sense to have a negative value. See, now it sounds different. This is how we can make everything work. Later on, well, we can edit the values. These are the values with a simple CH ramp. We know that this is going from 0 to 1 because it's normalized. So we are just basically using this ramp to change the values and clean it a little bit. Look at this. See? Nice. This is very nice. At the beginning, we don't have anything. But these are the values we're getting. And we can see we are just starting to do different kind of operations. The filter is going to just blur everything a little bit. You will see right here that everything is... I cannot even listen to it, to be honest. But if you go to the play, this is what we end up getting. I try to stay everything relatively nearly to the 1. Let's see if I can listen to anything. I can't really tell, but there is sound going on, and this is the curve that we wanted. Then the envelope is just, well, what they did here is the math is just to multiply it by a value. We can multiply it even more if we wanted. I'm not going to do it. The envelope, and the operation is just to the root. Basically, the negative values are going to stay negative and the positive are going to be multiplied. And the envelope is going to be resampling this to a sampling rate. That way, we are basically reducing. Look at these samples. This is so high resolution. There is too much resolution going on here. And what we did is to lower the resolution to something much more manageable. And then we are going to be renaming. We were working with the channel 1 because we deleted the channel 0, and we are going to be calling this bus. So this is just going to be our bus values. This is perfect. It's exactly what we wanted. Then on the other side, after the clean, we're going to be cleaning this differently. You can see it's just a tiny bit different. The first one from the second one, which is this one. Then we're going to be doing the same thing, just multiplying by the root. In this case, I just choose to use the 1. So it has a different connotation. We're going to be calling this same. I mean, I could have just put this on top, but it doesn't really matter. And then on the math, I'm going to be increasing this quite a bit, because in this case, I don't care if it's just over 1. In fact, it's what I wanted. And the area 1 is a really cool node. Check it out. It's going to be increasing. Cover your ears. Perhaps this is going to be a little bit noisy. Well, I can't really listen to it. Perhaps in the video you can. But basically this sound is going up and up and up. And I can control with the area how much is the offset. But basically the control is roughly around here. See? There we go. And this is all that we need to make like somewhat of adding noise. This will be for the offset of the animation. We're going to be renaming this, you can see, to combust. And finally, this is a very cool one, the high-pass. So we're going to do the same, limit this right here. And we're going to be cleaning this again, just a different operation. You can see it's moving the low values to 0 to create this sharp thingy. But the only difference is that in this case, the bass was different, and we just kept the what's the name? The high pitch sounds. Sorry if there is any musician here, but this is the only thing I got. Okay, I wanted this sound to stay. Why? Because I don't know. Because I don't think I use it. No, I didn't use it in this case, but it's nice to have it. Same thing. Envelope, filter. This filter is quite nice. It's just a way to make this a little bit cleaner. You cannot even listen to this. Rename and out high. Even if we merge all the channels, we can see all the channels at the same time. And you will see bass, acum, bass, and high. Then we're going to shift this a little bit. In this case, this is very important because this is, how can I say it? We don't want this to be calculating each frame, right? So what we're actually doing, let me just show you, is sending this backwards in time, as you can see. So in the first frame, what we are doing is offsetting this to 1001 frames. So these are the values that are going to be ingested as we speak. This is everything that's here in this line are going to be our values, and are going to be what we are going to be getting from this frame. On frame 1272, we're going to be getting this value right here, and of course this value right here. I know it's kind of confusing, but this is like the best way to send information to subs without exploding your PC. Is making all your adjustments and just dragging it at the same time of the FPS and negatively. So basically, then you send this. See, this is static. This is rig. It's static, but it's actually animated somehow. And if it were animated, our computer would explode, at least with this. And these are all the data. As you can see, this is changing as we speak very nicely. Excellent. And what I'm going to be doing is just to stay here. You will see that this is the same offset as this. So you will see that we get all the boom, 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 everything that we need. So let's create the ground. This is very easy. We create a grid, a very, very, very long grid. Let's see all the subdivisions. It has quite some subdivisions, not many. And these are some operations. We have 30 by 400. And what we did is to the size y, being basically x and y, this one is divided by 2 and added by 20. This is so that if we were to add more things, the grid stays on the same place. The math is simple. Half of this plus something is going to be basically these 20 meters. You can see there are 20 meters here. So if we didn't add those 20 meters, it would just stay on the half, but we wanted it here. And the rows, this is a very clever thing because I want to have squares. I always want to have squares no matter where we are, because the displacement in render time is going to be very, it likes to have squares, to have quads. So what we did is to the rows, so the size y is going to be divided by the size x. So we're going to have a relationship, and we're going to be basically we're going to be multiplying this by the columns. At the columns, this is going to be the density of the x. How many squares we want in 30 meters. So it's going to be this multiplied by this value, and then the ratio between those multiplied by these values. So it doesn't matter what we have, we're always going to be having squares, as you can see. It's just not going to be changing whatsoever. It's all the same. It never changes, which is then we're going to be subdividing this because I want more squares. I also like squares, and we're going to do a UV unwrap of this value right here. And this is what we get, which I don't like this. I don't really like this. I'm also going to be keeping this rest. I don't know if I used, but I always like to have the rest position stored in case something happens. And we're going to be transforming this. So the scale is going to be the size y divided by the size X, because we want to have the ratio. And again, it's going to have the ratio. Basically, this is the scale, so everything is square, the UVs and also the grid. So if we were to change something, you will see that the grid stays the same. So this is going to make our life easier when we add textures, because the textures are going to stay relative to our grid. They're not going to be, I think they're going to be in local space, not in world space, if I'm not mistaken. Basically, I'm going to have, no matter what, one UV tile here. No matter what. If I were to change this, you will see it just reduces, but it's 1 to P, and in this case, also going to be 1 to P. So no matter what we do in the materials, we're going to be having the same pattern. Even if you make it bigger or smaller, the displacement is going to be changing, of course, but the texture not. Then we're going to be changing this right there. I don't know why I did this. This is overcomplicating my life and yours. I don't know. I decided to do it this way because the project changed as we spoke. I mean, as it was created. So then we added a mountain because I want to have some surface imperfections before we add everything. These are the settings, just this. I don't know why this is like this. This is a visual book. Oh, it's like a material linker. Interesting. Very interesting. Let's just use this then instead. So these are the values that I use. I mean, it's just a simple noise. There's nothing crazy about it. And then a transformation. You will see that I'm using the accumulation and bust. So how do I do it? It's just, as you can see, I'm grabbing the data from here with the point, grabbing the node, the 0, the attribute I want from this geometry. Oh, sorry. From this geometry, from this point. Multiplied by the channel, which I added. The way to add is parameter interface, and then you grab whatever you want and you drag it here, you name it. Right click, copy, and paste relative reference, multiplied by also a value that I wanted. In this case, it was this value, 3.35 roughly. This is also going to be added by this expression. Why? It's going to be added by basically the time negative subtracted by our time. So it's going to, instead of starting on 41, which is our time in seconds, it's going to start from 0 and then start to add onwards. So it's going to be 0 plus this multiplication, which is going to be our translation. And you will see that this is going to be changing with our bus. And also, it's going to have a little offset always. It's always going to be moving, but the bus is going to accelerate this movement. See? Nice. And then, right here, what we're going to be doing, let me show you. This is an attribute I'm going to be sending to later on. This is after the translation. What we are doing is basically calculating the magnitude of the position, which is going to be outputting a float. Basically, the farther you are, the bigger you are on this value. And then I'm going to do a band ramp, as you can see here, which we are going to be using for controlling the band attribute later on. It's just a seed ramp with a fit on the magnitude, which goes from 0 to infinite. But we're going to be just grabbing 0 to 300, and we're going to be remapping this to 0 to 1, so the ramp works nicely, and we're going to be getting this ramp. You will see that we're also going to be bending this. We calculated that -1 and 1 with a presenter having 15 meters. Because why 15 meters? Because our grid is 30, and 30 divided by 2 is 15. So we're going to be just bending this, and we're going to be deforming both directions, and the bend attribute is going to be our mask. So if we were to change this, our bend is going to be changing. What else? So we have this. Excellent. These are the capture length also. And remember, we have a camera. Right now it looks kind of strange, but when we add another band, you will see it's going to look much better. If we press play, this is what we have. Okay, it has a shift. That's why it's not following the sound. But of course, I fixed this on the After Effects composition. See, nice. So it's going to be bending as we move forwards. We're also going to be translating this a little bit, just to make it so I like the transformation a little bit better. We're also going to be adding trail with compute acceleration for the motion blur. This is the motion blur. I mean the velocity vectors. And this is how it looks. And later on, we're going to be deleting everything that's less than this threshold in the band, because otherwise we would have almost 1 million polygons, which is insane for the subdivision in Karma. We're also going to be deleting this with the sphere. We're going to be deleting with the bounding sphere. This is just, hey, what's your band attribute? Is it less than this? Yeah, delete the points. That's all that's going on. And we're going to be setting this to disk. As you can see, I might have changed something. But it basically looks something like this. Let me show you from camera. Yeah, what I did is probably when I was speaking, I changed this band attribute. There we go. Something like this should be nice. So if we press play, and there is a nice trick. See, this is waiting for the song to play. But if you go to the audio panel, no, sorry, if you go to this one, global animation, you can play every frame, but never faster than the FPS, or maintain real-time playback, possibly skipping frames. This is a really nice way to work with sound, and look at this. It's going to be skipping frames, but the music is going to be staying, which is good enough for me. So we have this, and that's how we made the ground. Moving on, we added a torus. Now the torus is just a simple torus. And we did two things. Let's go with the basic one, which is adding a UV unwrap and then transforming this. And the transformation is just grabbing this transformation right here, which we use for the scatters. This is a scatter with a rest position because it has to have the rest position always. And I'm transforming this with the data from the Acum bus multiplied by 5 and adding 45 for an offset. And the same is going on here, but multiplied by 5, no offset. And this is what's going on. See, it's just moving. Well, the same transformation is just here, it's a reference, and it's doing exactly the same for the UV unwrap. It's moving nicely. This is torus moving, which is going to be used right here for something which is going to come after our simulation. These are the trails for the velocities, and this is the torus. So this is a torus, which is, we're going to explain this in just a bit. Now, we save this cache. It's always nice to save the cache because sometimes working with chops can slow you down. Once we have this cached, we're going to do two different types of source, which are very similar. Let's go and look at the mask. This is the mask. It's just a mask float with another ramp. And that's how it is. And remember, I'm using the rest, so it doesn't move in place. It stays with the original position. It has a slow animation, nothing else. We're also adding another one, which is going to be just adding to what we had before. But the trick is that we just reduce the offset a little bit and we remove the remap. That is basically the same. We have these two things. And we're making a couple of things here, which is for the contrast. The only one that you need is right here. These ones were older, so we're going to just delete this per parameter. We don't need this, and we also don't need this. This was from another test. So we had this, that is the contrast we can add later on. It's just a search ramp grabbing the mask and contrasting it because it's from 0 to 1. And well, then we're creating the attributes. The attributes are, well, firstly the mask. We're going to be multiplying this if we want here or not, and just mapping the density, temperature, the burn, and the physical to the mask. And we are obviously adding the trail for the velocity. And right here we are just adding, because we're keeping the coming velocity is going to go upwards. and we're going to have a little curl. So this is what we have. This is what we had before. This is what we have now. This is going to be quite noisy. And we're going to be retiming this with post extend. You go by time. You interpolate between input frames. You set the frames right here, which is in this case our timeline, and we go to post extend. This is for the substeps on the Pyro solver. We then are going to be rasterizing this with these settings. Normalized by clamp coverage is nice. I always try to use it. Well, that's about it. You will see we have the volume right here. We could save the substeps. I mean, this is quite fast to load, to be honest, so it doesn't really matter. And for the right, we did something but smaller. It's the same but smaller. As you can see, the element size is very small. And we added some contrast. Remember, again, this is not used. Neither is this. It's the same idea right here. The same idea here, but with the double the force. This is the same trail velocity, the same point velocity, the time warp, and the rasterization. This case is probably a little bit harder to compute this. Yes, it is, because I'm using way more resolution. But still, it just works. So then, after you have all the things, we could hop into our Pyro solver. Now, the Pyro solver has a nice thing. In this case, I'm using GPU, if I'm not mistaken. Yes, I'm going to just reduce for a moment. I'm going to just be saving this just in case, because sometimes I can crash. And we're going to be showing you what's going on here. Well, let's just, it's loading. Okay, so this took a time to load because firstly, we are with minimal OpenCL GPU, basically the minimal solver. And we have 6 substeps. So if you were to have a file cache here, you will probably want to have 6 substeps on the file cache. The substeps are this thing right here when you save anything. In this case, I decided not to because it was a very small project, but you should. The fact that I didn't do it doesn't mean that you have to do the same. So there are a couple of things. Firstly, when you work with the minimal solver, let's just say you want to work with less resolution that I have because you don't want to destroy your PC while you work, right? So let's press play. See, right there. And you can see that, let's just grab this Pyro's volume here, Pyrobake volume. You can see that in this case right here, I am working with a very reduced bounding box. Because when you work with GPUs, you want to stay close to your camera, basically. In this case, this is the camera. And I realized that I didn't need much more space than this. This was more than enough. Now, what are the things that I'm using here? Let's stay with this. Firstly, the temp scale is set to 2 because I want the fire to be moving a little faster. The substeps are 6 because it creates a better whirliness, let's say. This is the bounding box. The sourcing is going to go from 1100 to 1300 because beforehand I didn't just have the necessity because there wasn't anything going on. And I'm using the bass as the scale, you can see. So this bass is going to be controlling our emitter. This is very nice. You should have this here instead of here because if you were to do a change, well, it's not going to be recalculating the source ingestion. We're going to have the density, the pool, the temperature. This is the basics. The burn is going to be setting to the flame. Everything's going to be having the same. So this is the trick. I'm using the chopnet to, as you can see, to control the pyro simulation. On fields, I'm just going to having the flame to 0.5, so it stays less time than usual, and I'm going to mid temperature from flame just a little bit. The default is nice. And on shape, I'm going to have less buoyancy because I don't want it to rise so much. And advanced, this is very important. Then I'm going to use this advection method, which looks better. On the output, I'm going to be outputting all this. I used to have alpha and CD before. In this case, I'm not using it anymore. so you can remove this. And inside here, I'm going to have a gas turbulence with a scale of 5, a scale of 1, and a disturbance with a scale of 0.02. These are the settings of the swirl size and this swirl size. As you can see, they are like one is big and the other one is half because you want to have different layers of detail. The control is going to be the speed. You will see that in one of these cases, I always have a little bit of swirliness, which is in this case, it is the big swirl, and on the other one, I'm just going to have a like super fast swirl on where it's fast. This is the control max. Basically, it's like the top part of our velocity. And on the disturbance, the same, but for with the temperature. And on the binding, I'm actually using this threshold to be disturbing, because I don't want to disturb the density necessarily. I just want to disturb everything that's the flame. And I'm using OpenCL. Remember, if you are using minimal solver, you need to have the OpenCL turned on. Now, that's all there is. If we were to go into more resolution, we can press play again. Nice. And this is just to pre-visualize. You can see that in the fire, I'm just using this ramp. So you can have more or less contrast to some areas. And this is after the Pyro post process, which basically is used to reduce, just click everything. It's just to reduce the volumes. We are going to be converting the volumes, combining the velocity, converting to 16 float instead of 32, cooling, whatever. We're going to be having this out of this, which is way more. And on the final one, you can see there is much more detail because, well, it was double the resolution. This was set to 0.5. This is the fire we're going to be using to render. Then we're going to be doing a trick, which is resampling this by 2 with voxel scale, and we're going to be saving this for a low res visualization. You can see we are having the same error as before because we had this differently. And now we can see it's going to be skipping frame, but it's going to work. But perhaps not so much. It doesn't matter. It's you get to know that this is working in real. It's working. You can obviously create a media. Okay. And this was the test. Let me show you the effects. No, not this one. Let's see if I have something. Okay, so the trick is to basically grab. So the trick is to do flipbooks with your camera, and in Premiere or After Effects, make, well, have the sound exported, and just play with it. Also, what I did here is to, from this, which is what we are going to be using, or basically this one instead, just export into the heap the music, because this is changed, of course. We trimmed it and we're not going to be using the same. And these are our fire, our high and our low. Now, if we move forwards into the torus, you remember where I saved it to the animal object. What we're going to be using is this section right here. So this is very important for the UVs and for the texturing of the torus. What I'm doing here is to just grab the torus, do a simple scatter, time shift this to the frame that I want, and interpolate with the prim and the prim UV. Remember that scatter has to have these options turned on, the position of the points, as you can see right here. And then the fire low is going to just be for the flame, because I want to have the flame in my power. There is something going on here, because this is not visible. But when we set the attribute from volume and we click this to be the mask, we can see that wherever the flame is, there is a mask going on right here. And we're going to be doing a wet mask out of this right here. So let's go into the COP.net. And now let's open the viewer from the compositing. We will see that inside here we have a couple of things. We're going to give you the X and the Y, because we're going to be creating a U, the UV map. On the image, remember, this has to be set to whatever resolution went from your mask. We're going to be creating the UV and plugging it into the PC Open. The PC Open this is promoted, basically doing middle mouse click promote parameter, is going to be to grab the points. As you can see, OP, and you just copy and paste the points, which are this one, which has this attribute. Then when you go in, this is basically how much we're going to be looking for the points around, and we're going to be filtering the mask, which we're going to be clamping just in case, and setting this to the RGB channel. I mean, and just finding information near the points in a UV map. That's what I'm doing. And then we're just blurring this a tiny bit. Just a tiny bit. Which I don't think it's even doing anything. Oh yes, it is blurring. And then we're going to be saving this from frame 101 to frame 1300 and here to textures and $F4 AXR. So we're going to have a sequence of images which are going to be the mask. This is very important to have because, if I'm not mistaken, you cannot link this straight to material X, at least not yet. So this is all the effect. Now we're finally at the fun part. So the fun part is this one. We have the torus. We can also have the ground, which we are importing. And remember, always try to be organized. It is very important that you are organized. So I always try to put scene, background, geo, scene, background, geo. So we can have like a hierarchy of things right here. We're going to be creating the materials. In this case, we have two materials, the ground and the tube. We're going to be starting with the tube because it's easier. And we're linking these guys together. We don't have the background geo because it's just turned off. And then we have the camera. This is the camera that we have. And this is the fire. We're grabbing the fire and we're adding a little material. The material is super easy. It's just a karma material with these settings. Density is 72 with this color. And on the scatter, we have this scatter. So it has, well, some scatter. Let's go with CPU. Very, very nice. This is how it looks. We can change this, of course. It's not going to change that much. And the fire is, if we add a 0, it's going to burn a lot or burn very low. This is what we want to have. And on the bindings, the intensity was set to to flame. But we can also use temperature, which is going to be having another effect, which I don't like. I prefer to use flame as my driving intensity. So that's the flame. And if we go here into the tube, we can visualize the tube right here. You'll see it has like something going on, right? So let's just press here to visualize a little bit better. Now look without the material linker. You'll see it has something strange because it's not burning or it's not heated up. And in this case, it is. So we can use this with XPU too. If we go to XPU, this is going to load into the GPU and it's going to load way faster. Look how fast this is. Isn't it amazing? It's super, 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 super fast. Now, I render most of this in XPU. So, what's going on with the tube material? The tube material looks complex, but it's not. This is the base. It is metalness to 1, and yeah, it's just metalness to 1. And then what I did is to actually read the UV and multiply this by a value to create, to just create like a noise. Let's just turn off for a moment the fire. There we go. And let's go into the material again. So we can remap this. So I can show you this is the noise that we're creating. If we were to multiply this by another value, the noise is going to be smaller or bigger or whatever. This is what we want. It's just to have a tiny bit of noise. But basically everything is going on here. This is the image we have. As you can see, remember, it's just our plain mask and it should be set to $F, which is this one. We want to make this relative because I forgot. Again, relative. Okay, so it doesn't really want to change to relative. So I'm going to change this. There we go. I changed this to relative. So it's inside the project. And then I'm just remapping this to have a way to control this, as you can see, how much we want. And what I'm doing is firstly using this as the emission, but using this as the color. And the color ramp which I use is exactly this one. We can do whatever we want here. If we move this here, it's not going to do much because we're going to be multiplying this by 3. So this is the value. See, we can control the intensity of the flame or of the emission right here. If we were to change this, nothing is there. The mask is going to allow us to have the color. That's all there is to the tube. What else? Well, we need to have the ground right now, which I'm going to be, as for the moment, lowering the dicing quality. This is just optional, so it's a little bit faster to load. It's going to be compiling. So what's going on right here? There are a bunch of things going on. Firstly, I'm using 3 different textures. One for the diffuse, which is a rock texture. Let's see if I can open it. If I can show you, in fact, which is, yeah, this one is it. So this is the diffuse, which I'm using in 8K. You can see it's just a rock image, which has some roughness, which is the same roughness. This is the UV. I'm multiplying by 30 in this case. And basically this texture, let's just disable the dicing overall right now. So what I'm using here is just a simple texture to UV. If we press 1, it's going to be much bigger. If we press 30, it's going to just reduce because I'm grabbing this UV. I'm mapping it right here. And this is for the displacement, which I'm just remapping to -1 to 1. And I'm having this displacement right here. And then what I'm doing is to just having, well, I'm mixing both displacement from different textures. One is this one. Let's see if I can show you how it looks right here. So this is another displacement. It doesn't look like much because it's actually very white, but when we remap this from 0 to 0.7, it's going to look a little bit different. And here we are remapping this a little bit more so we can have some contrast. And you will see if we zoom it very, very close, we have some pattern. This is going to be destroying our displacement because beforehand we had this displacement. It's loading, guys. It's loading. This is the displacement we were having. That front camera looks something like this. One displacement. Remember, there are negative values right here, so we cannot see everything. That's why something is black. And the same goes to this one. If we add both of these maps, it's going to be way better for us. It's going to have little details and big details. These are the big and these are the small details. So we're going to have 2 displacements on top of each other, which are going to be giving us much more detail whatsoever. So let's go and adding this, and let's just work around adding a little bit of displacement. So let's do 0.3. You will see we have a lot of little details. This loaded really fast because we optimized the mesh. And I want to show you how it looks without the second displacement. So let's delete this. As you can see, it's nice, but we are missing all those little details, which were very nice beforehand. And the mix is just 2.5, so we have a mixture of both displacement maps. If we go to 1, we're going to just be having the big details. If we go to 0, we're going to be just having the small details. And 0.5 is going to have a mixture of both of them, which is what we want. And that's the material. There's no much to it. There's no materials to it. So we're going to be changing this. And we're going to be adding the fire. And we're going to be adding a light at the back. As you can see right here, it's just a sphere. Very nice. And we are going to be starting to do our render layers. This is what we want. Before this, I usually try to work with a test render geometry. In this case, this is where I render the tests. Very nice. And the settings are basically acceleration motion blur, because we had acceleration. We're going to have all these limits, so we can have nice bounce lights. We're going to be using XPU because it's very fast. And we're going to be splitting this on with the LPE. The LPE is just this, which I forgot to show you. When you go here, we can name the LP tag. That's all there is. I'm just having a tag, so you can show you later. The long light is just a simple HDRI, which this has to, of course, be relative. Oh, this can't be relative. So then this was a test thing I did. It doesn't really matter. And on advanced, I'm using bucket. So this is what we have. But we can see the ring light and the emission and the ring light, the HDRI. What else? I think nothing else. Oh, this is a test thing I did, which shows you a map which is exported from, if I'm not mistaken, from the ground. Is this one. It's just a mix. I'm just copying these settings right here and mixing both maps, but without the displacement, and showing this null. It's just easier to see. And that's all there is. And here I'm phantoming everything. Basically, as you can see, everything is very organized. Super organized. Camera, lights, materials, the background and the midground. So I'm removing the primary light from everything. And on here, I'm just setting the displacement to 1.5. I'm not going to show you this because my machine is going to explode if I show you while I record. But basically, then I'm setting the displacement to 0 in this case, because if I'm going to rendering the midground, which is the disc spinning, or the volume, which is just the volume, I don't really need to dice the background. It doesn't really matter. So the dicing goes from 0, so it's faster to load. And then I'm just grabbing again the geo and rendering the visibility back again. And in this case, I'm adding an option just for my geometry, which basically is doing as matte, and then I'm visualizing my fire. Without this, I will see everything. With this, I'm mathing this, which, let's see if I can show you with this in dark. Let's see if it's visualizable. Yeah, in this frame, it's not visualized, but when you come this in Nuke, it's very visible. The same render settings as the other one. And this is just from Prism. This is a tool from Prism, which I use to send everything to Deadline to render faster, because I have some computers. You would be using this one if you don't have Prism, but I highly suggest you. This is just a tool, which, as you can see, is just this same render, but it has some options right here, which you're never going to be touching, but it works. Once you have all this, we are going to have in 3 layers: the background, the midground, and the foreground. Let me just show you in Nuke later on how this would be looking. To finalize this, we have the Nuke file, which it's always nice to be very organized and with a lot of space. So I created a blank, a dark background with the same resolution of my render. Then I grabbed an image from Google. I reformatted this. This is the root file. I reformat this, so its resolution is strange, so I reformatted to my resolution. I color corrected this a little bit, and not much. I mean, it's changing something, and then I graded a little bit, so it's matching to what I want, and I transform this. This transformation is just doing this. Look at this. It's just a zoom in, nothing else. Super lazy. Then I'm going to be doing the beauty. This is the background, as you can see. Super nice. And I'm splitting on I'm shuffling the ring light, right here, the HDRI, and the emission, if we were to have. And I'm then copying the alpha, because otherwise the alpha would be, as you can see, they would be adding on top of each other. So I'm just overriding this, and I'm unpremulting this, because all the color correction you want to do to this has to go with unpremult. Then you do the color correction and then you premult, so you don't lose detail on the borders on the alpha. You should always look at this. There we go. But yeah, this is the correct way to do it. And then we merge this. This is what we have. Very nice. This is integrated the color with the background. And I'm doing a roto. You will see that this roto is something like this. It's just a simple roto. I'm shuffling this to the depth. That way I can fake the focus. It's the focal distance. I'm faking it because I forgot to export the set map. But that's, I mean, it's super easy to do this, so it wasn't a problem. I didn't want to render a new tech. So this is the new beauty. Same thing with the mission. All of these things are added, and I'm blurring this just a tiny bit. See, I'm blurring it to have more integration because this doesn't have any defocus whatsoever. So I just fake it with a blur. Then we're adding the fire, and the fire is quite nice because I'm having the fire, also doing everything this. I realized that I have 2 times the smoke, but it just looks nice. Interesting that I did this. Oh, because I just kept one of those. I could just use this, but the fire, I mean, the smoke didn't quite look as I wanted. And also blurring this a little bit. In part for the denoising, because I didn't want to do a denoise, and in fact to integrate it a little bit more with the sharpness of the shot, which is not that much. I use a compositing stamp right here, where I added a glow with effect only with this size and a smaller noise with less saturation, and merge both of these with a plus, and then with that over, what I did is to add it on top of it, as you can see. One I think to have, let me show you if I'm not mistaken, somewhere around here, there was a trick that I used to add the layers, which I'm not finding right now, which is something the union set instead of B to B is set to the A, because sometimes you can have a bigger bounding box, like in this case. Well, this is added, and I used to have a color correction here, which I didn't use, and a little transform, which I still didn't use. Then the same thing, the postage stamp, and grabbing the alpha and right here. So this is what I'm using. I'm blurring this a lot and grabbing the color correction to make it a little bit more visible. This is how it looks, the Luma key. And grabbing this image that I have, reformatting it, grading it, blurring it a lot, and multiplying it with the color correction, which is this one. So whenever there is fire, it's going to show us the lens test, and I'm going to add this on top of it. And then the reformat, this is so we can remove those pixels. We're going to be adding a little bit more of color correction, adding more contrast, basically. See, I like this a little bit more, doing more color correction, bringing the blues bigger. I mean, having more blues, having a little bit more violets. So, yeah, this is perfect. Then I'm grabbing, adding a radial grade, blurring it a little bit more because I like the blur. Cropping this, as you can see, I'm having a pixel that I didn't want, or adding it. Then I'm having a lens distortion. These are the settings, just so I can have like a fisheye kind of thingy. Transforming this to make it bigger, and adding on top of this grain. I always like to add grain to it. These are the settings, basically to make the noise very small and not so intense. And then saving this, of course, saving this as output sRGB, because all of this was done with ACES. If we press S here, we can see that we are using the view transform of ACES ZG, I mean sRGB. And that's all there is to this Nuke file. I hope that you like it. Thanks for watching the tutorial. Please, as always, leave a like, subscribe, comment, I will be there for you. See ya, guys.